Okay, we are going to go ahead and get started. This next presentation is Pydantic Power Up Performance Tips for Lightning Fast Python Applications by Sydney Runkle.
Hello, everyone. I'm excited to speak with you today about Pydantic and its awesome performance. So this is what we're going to talk about today. Just a little intro about me and Pydantic first, then we'll cover some basic kind of one-liner type performance tips and improvements. Then kind of the main meat of the talk is going to be using tagged, or also called discriminated unions, and then we'll do a conclusion and Q&A. So a little intro. I'm I guess long time is relative, but long time small business developer. I just graduated from UW-Madison on Sunday. So I'm now 20, but since I was 15, I've been working for small businesses across industries, so insurance, just kind of data analysis, finance tech, and now at Pydantic. Currently the lead maintainer of Pydantic, and I also do some technical writing, and in my free time, I spend most of it outdoors. Alrighty, so what is Pydantic? If you're here, you probably already know, but Pydantic is the most widely used data validation library for Python. So we make it super easy for you to use type hints to specify model structures, and then you can very easily validate and then serialize that data. So there are a lot of reasons to use Pydantic, listed a couple of them here. Today we're really going to focus on the speed component of it, but as I just mentioned, it's powered by type hints, very fast, especially now that we have released V2. It offers custom support for JSON schema and then consequently automatic documentation generation. We also offer customized validation and serialization logic. There's quite a robust ecosystem of tools that use Pydantic, so you're probably most familiar with things like FastAPI, Django. There's also SQL model. There's a very long list of these, many of which are represented at this conference, which is awesome. Then there's also just an extensive and inclusive community kind of around the tool, which is great. As I mentioned, one of the reasons why Pydantic is so fast now in V2 is we use Rust at the core of Pydantic, so all of our validation and serialization logic happens there, and then we have this kind of Python wrapper around it that makes it easy to use. So jump into the basic performance tips. First, I'm going to talk about opinionated JSON loading syntax. So that means if you're trying to validate data that's coming in with JSON, we kind of have a recommended way to do it. So we recommend that you use this model validate JSON function. It's kind of a misconception that you could use model validate and then JSON.loads and then your JSON string within that, but that's less performant. And the reason being, when you use JSON.loads within that model validate call, you actually materialize that data as a Python object, whereas if you use just the model validate JSON that we provide, that only materializes as a Rust object, and so you get to skip a step, which makes it more quick. The exception here is in the case of some model validators, which is one of those kind of custom validation features that we offer, such as before model validators and wrap model validators, it doesn't really matter which one you use because you're going to have to do the Python realization of that object anyways. So kind of an exception case, but in general, we recommend the model validate JSON usage. All right, so I'm going to cover this very easy performance tip, which is with TypeAdapters. So Pydantic TypeAdapters allow you to take a type, in this case, a list of integers, and then validate data against that type. So it's a little bit of a shortcut. You don't have to define a model with an abundance of type annotations, et cetera, if you just have one type that you want to validate data against. So what I'm showing here on the left is what you don't want to do, which is initialize said TypeAdapter object with every function call, or if you have a loop, you don't want to have that initialization in the loop. What you really want to do is the approach on the right, where you initialize the adapter once. The reason being is because we build the core schema that kind of defines those type structures every time you initialize the type adapter. So doing this approach on the right is going to save you lots of time. And then my last kind of basic performance suggestion is to use the most specific type hint that you can in the case of sequences and mapping. So we allow you to use the sequence or mapping type hints if you'd like, but I'd recommend if you know that you have list data coming in, just use list, because then you're going to skip the is instance check on the sequence, and then you can also, just immediately go to the list validation, which is going to be much quicker. Very similar advice applies to the mapping and dict case. So that's kind of a collection of tips that you can use, even just like 1 or 2 line fixes. They're going to speed things up for you. Now we'll sort of move on to the more general content of the talk, which is using this structure called tagged unions. We also call those discriminated unions. So we're going to talk a little bit about what they are, kind of cover a basic example so you can wrap your head around the idea, then talk about why we use them, giving you a little bit of a preview here. Surprise, surprise, performance is one of the reasons. And then we also offer improved error handling, JSON schema support, and then we'll go into some more advanced examples with those discriminated unions. So tagged unions are a special type of union. A union is just a type where you're saying, this thing could be either type X or type Y. You can have an unlimited number. And when you're using a tagged union, you specify a specific member of those union types to discriminate against. This will make a little bit more sense when we cover the example on the next slide. And you can either have a string type discriminator, so that is if you have one field in each of your models of the union, you can just use the name of that one field as the discriminator, or we can use a callable type if you need to do some more complex analysis there. So let's look at an example. Kind of the classic pet case here. We have pretty similar classes with like a cat, a dog, and a lizard. You can imagine that these classes would have, many more features or fields per class, but I'm just going to keep it simple with 2 each. And I have this pet type literal associated with each class that kind of identifies it. And so we can use that pet type literal as the discriminator in this case. So if we build a model class that has a pet field that's a union type of cat, dog, and lizard, we specify the discriminator as that string pet type. And we're just using the Pydantic field constructor here to provide a little bit more information for that field. So then we can see we initialize model instance. In this case, it's a dog. And what's really happening under the hood here is that with a standard union, Pydantic would attempt to validate your incoming data against all of the types of the union, and then find which one was the best match. So the result here is going to be the same, whether or not you use a tagged union or just a regular union, but this is much more efficient in that we check what the value of the pet type data is coming in. We see that it's dog, and then we only validate against the dog class. So you can imagine if you either have a union with many, many members, or if the members of your union have many fields, this is going to be much more performant. So, as I mentioned, one of the top reason really why you'd want to use this is to have more efficient validation. So avoiding validating against all of those union members, beneficial with nested models in particular. So if you have lots of models with models within them, or even just recursive patterns, this can help to skip a lot of those union checking steps. Because if you don't skip those steps, especially in the case of nested models or recursive cases, you can kind of end up with exponential validation blow up there. Tagged unions also offer improved error handling, which is quite wonderful. So here's an example of validating data with a union type, and we're not using a discriminated union here. So you can see that this is a bit of a nested structure. The X field of model can either be of type string or the model type, and then we're validating this kind of nested structure. And you can kind of see what the validation would look like for a typical union here, right? We first validate against, X dot, or the, first X case on that outermost one, and then we move inwards. And it's a little bit hard to interpret these errors, and so you can understand with even more nested models, that's definitely something that we want to improve. So here is, I'm kind of introducing the callable discriminator in this slide as well. So we have this model X discriminator, which is going to be our callable. And then we have the exact same structure as on the previous slide. So let's just recall we have X, which is a union of string and model. And then here we also have X, which is a union of string, which is tagged with this string tag, and then discriminated model, which is tagged with model. And this callable discriminator basically allows us to pass in the data and determine which of those union members we should discriminate against. The custom error type, custom error message, and custom error context here are just included to show when you add that extra information, you can really simplify the error message. So here's an example of creating an instance of the discriminated model with invalid data, and you can see that this is much more straightforward in terms of the error that we're getting. So this is sort of a double-edged example in that we see both the more efficient validation in the number of errors that we get, and then also the just kind of improved and more clean error handling. JSON schema is one of the reasons why so many people love Pydantic. It is really supportive for documentation and then also just adhering to the general JSON schema standards, make it quite versatile for things like API usage and web requests, et cetera. So we kind of go back to the cat, dog, lizard example here. We look at the general model down below, which is what I'm showing the JSON schema for in terms of the pet field. So the nice thing also is that JSON schema supports a discriminator tag, and so we've included that here, and then you can see kind of the general mapping for each of the pet types. All right, so I'm going to go into a little bit more detail with the callable discriminators. Kind of the application before was a little bit hand-wavy because I was mostly focusing on the improved error handling. So the reason that callable discriminators are helpful, although they're slightly less performant than the simple string discriminators, is that they allow for slightly more complex discrimination behavior. So let's say, in this case, you want to use the type of the field V, or of the V data to determine which model you want to validate against. You can do that with a callable discriminator, but not so easily with a string type discriminator, which can only discriminate based on a certain field's literal value. Another extension for callable discriminators that is quite helpful is, let's say you need to look at two fields in order to determine which model you want to validate against. Like maybe you have a student model and you have like an age and a city or something. You can kind of use combinations of fields here, but it's still much more performant than if you were to go and automatically validate against 100 fields that your kind of bloated models had. One of the best cases, in my opinion, at least where the performance benefits are the most evident, is nested models. So here we have a black cat and a white cat. You can probably see where I'm going here with my animal cases, but we use a cat type at the bottom where we have a union of the black cat and the white cat types, and then we can just annotate it with that Pydantic field constructor that we've seen before, and we're using the simple string type discriminator here with color. And so we have that annotated cat type, and then we can take a union of that with our simple dog type that we've seen before to get this more complex pet type. So kind of as a recap, that pet type is either a cat or a dog, where a cat can either be a black cat or a white cat. And then we have our similar model where we just have a pet and then the number of pets. So in this case, we are validating data corresponding to black cat. And once again, the value here is just that we're able to skip validating against the dog model entirely, and then we can also skip validating against the white cat model and go straight to validation with that black cat model. Whereas with a traditional union structure here, we would have validated against all three of those data structures. So gonna move, it says conclusion and Q&A here. I still have a bit more to cover. We have a lot of performance improvements in the pipeline that are primarily related to our internal Pydantic core logic. So once again, in Pydantic v1, we had everything was written in Python. We used Python for some internal speedups. But now we have our core validation logic written in Rust. And Rust is much faster than Python. And so as we look towards these performance improvements in Rust, we're really looking at how can we keep data in Rust longer, how can we avoid materializing Python objects, and even in some cases, how can we avoid materializing Rust objects as well. So the first kind of performance improvement in the pipeline is using SIMD and jitter, so that's single instruction, multiple data, which basically means that we're using vectors and almost this form of like parallelism to process chunks of data at the same time. We actually have this supported for Macs right now, but not other structures, so we want to kind of fully support that in jitter. Jitter is our JSON parser. And then the next improvement in the pipeline is we're working on parsing JSON as validation happens. So right now, if we use the model validate JSON structure that I suggested in the very first slide, we bring data in and we materialize it as a Rust object, not a Python object. That was kind of the don't do this approach. But we still materialize it as a Rust object. And so what this approach would help us do is validate as soon as we get that data in so that we're not wasting the time and space to do that materialization. We also have an idea, perhaps we would rename this, or it might be named this fast model. That's kind of a lazy approach to these performance improvements. So what that would mean is that attributes aren't materialized until they're requested by a user. So data would just remain in the kind of Rust end of things until it was actually requested. I think in general, there's kind of a push to have more lazy evaluation if you're wanting more performance, and I think that's kind of the push that we would make in Rust. The one bullet that I have up here that's more of a Pydantic focused performance improvement is schema building speedup. So right now, especially in those cases of nested models that I was showing earlier or recursive models, we have to do a lot of passing over the schema to ensure that we've simplified references as best as we can. And so I think basically reducing the number of times that we can pass over the schema, though challenging, is definitely going to be a good step in the right direction for us. This is like an open source talk, so wanted to put a slide up here about contributing in general. We always welcome new contributors and appreciate issues with questions, bug reports, feature requests, etc. I suppose if you have questions, perhaps open a discussion instead of an issue. But I know you can get the little points on the back of your card if you open a PR and have that accepted, so I'll be watching the Pydantic repository all week. We have tons of things tagged with first good issue, and then also lots tagged with performance if you're interested in that, and some tasks in Pydantic core as well for that. Also, always helpful to just have people answer discussion posts, and or if you're not feeling super technical but want to still contribute, we have lots to continue to improve on our documentation. So moving to sort of an exciting announcement on the Pydantic end of things, we have Pydantic, the open source tool, which many of you have probably used and hopefully love, and we founded a company kind of based around the ideas we used to build that tool, really focused on developer ergonomics, et cetera. And we are now building our first commercial tool, which is called Pydantic Logfire, and it's now in open beta, so we would highly recommend that you try it. Our booth set up down below has some great graphics, but I'll just cover a couple of the benefits here. So it's an easy-to-use observability platform, and we use this kind of find the needle in the stack trace philosophy. Unlike other observability tools, we're really Python-focused, and so we have this Python-centric idea around it. We offer event loop telemetry and then also profiling your code. One of the most unique things that we offer is kind of this nested log structure. So whereas most logs have really taken this one-dimensional form that doesn't really make a ton of intuitive sense, given that code is often nested, recursive, et cetera, we actually offer nested logs. And then I have a couple of other bullets up here touching on other things like structured data and SQL access. Our tool is generally a very Python-focused, opinionated open telemetry wrapper. And of course, given that folks are quite satisfied with Pydantic as an open source tool, we offer seamless Pydantic integration, as well as integration with many other tools like Fast API, et cetera. And then here is kind of a screenshot of Pydantic Logfire. There, once again, we have kind of a video running downstairs showing a basic usage of that. Samuel gave a talk yesterday, kind of why did we go with this commercial tool. That was a great talk. Would definitely recommend looking back at that. And yeah, we also have a website, pydantic.dev/logfire, if you're interested in trying it out. But yeah, I'm going to open up the floor for questions, and I have some of our websites and documentation, et cetera, up here if anyone is interested.
Okay, if we have about 10 minutes until the end of this talk, we can take a few questions. If you have a question, please come back here, and you can ask your question from back here. Okay, well, doesn't seem like there's any questions. If you have any questions, you can always, I assume, catch Sydney at the Pydantic booth or out in the hallway, and I'm sure that she will explain everything that you would like to know about it to you. So once again, let's give her another